سلام جميعا. بدنا نبلش اليوم بدنا نحل بهيدي الحصة 2 exercises أو 3 exercises، 2 من البوكلت وواحد official exam. First exercise is number 33. Number 33 يكون أي page 136. Number 33 page 141. Again, it's number 33 page 141. Page 141, we have as a given u0 equal 3, un plus 1 equal 2 over 1 plus un. Prove that the sequence or the terms of the sequence are positive. So we have to prove by induction that un is greater than 0. Okay? So by induction, for the first term, for n equals 0, we have u0 here 3 is positive. I'll assume that this property is true to the order n. And show it's true to the order that it's true to the order n plus 1. لكن صار عنا given true to the order n بيعطينا إنه un is positive. for RTP show that it's true to the order n plus 1 بيعطينا إنه un plus 1. We have to show that un plus 1 is positive. هلا له proof معنى un plus 1 equal 2 over 1 plus un. 2 is positive. Well, 1 is positive, well, un is positive, لكن 1 plus un is positive. Again, then un plus 1 is positive, again, property is true. Part 2. If the sequence un is convergent, show that the limit L is a solution of the equation L square plus L minus 2. We have the sequence un is convergent, so limit as n tends to plus infinity the un equal limit as n tends to plus infinity of un plus 1 equal L. So we replace this symbol L, or this value of L, in the recursive relation L equal 2 over 1 plus L. L is over 1 cross multiplication L plus L square equal 2, so we obtain the equation L square plus L minus 2 equal to 0. Of course, if we want to solve this equation using calculator or the discriminant delta, we'll find that L equal 1 or L equal minus 2. But L equal minus 2 is rejected since we proved that all the sequence is positive, so the limit is L is equal to 1. So that's how we solve number 33 parts 1 or 2. We still have to solve parts 3 and 4. هلا part 3 معي هلا Consider another sequence Vn defined by its general term un Vn equal un minus 1 over un plus 2. Show that the sequence Vn is a geometric sequence. To show that Vn is a geometric sequence, we have to calculate Vn plus 1 over Vn. But at first, we have to find Vn plus 1. So I'm gonna find Vn plus 1. To find Vn plus 1 in this recursive relation, I will replace n by n plus 1. Vn plus 1 equal un plus 1 minus 1 over un plus 1 plus 2. ID1. Then I'm going to replace un plus 1 by its value. Un plus 1 is equal 2 over 1 plus un minus 1. Its value in terms of un. يعني I'm going to replace un plus 1 by the recursive relation in terms of un. Over 2 over 1 plus un plus 2. So in the numerator, I'm going to take 1 plus un as a common denominator. We'll have 2 minus 1 minus un. And in the denominator, I'm going to take 1 plus un as a common denominator. We'll have 2 plus 2 plus 2 un. So I'm going to simplify by 1 plus un. I will obtain 1 minus un over 4 plus 2 un. So to show that Vn is a geometric sequence, we have to find Vn plus 1, that is equal 1 minus un over, I'm going to take 2 as a common factor, 2 into un plus 2 over Vn is un minus 1 over un plus 2. At first I'm going to simplify by un plus 2. I will obtain 1 minus un over 2, and we have here un minus 1. 1 over un, we can take minus as a common factor outside. It will be un minus 1 over 2 over un minus 1 over 1. Now I can also simplify by un minus 1. I will obtain minus 1 over 2. The answer is a constant number, so Vn, geometric sequence with common ratio q equal minus half, and V0, first term V0. V0 equal, I just replace n by 0 in this relation, u0 minus 1 over u0 plus 2 equal u0 3 minus 1 2 over 3 plus 2 over 5, 3 or 2 over 5. Okay. And determine its limit. To find its limit, we have to find the general term. Yani, we have to find Vn in terms of n. As we know, Vn equal V0 times, the common ratio we called QR, not we used to call it R, not Q. Vn equal V0 times R power n. In French, they call it Q. The students that take math in French. Again, Vn equal V0 is 2 over 5 times the R common ratio is half power n. Vn equal V0 times R power n. It's not half, it's minus half also. Minus half. Now I have to calculate limit. Limit as n tends plus infinity of Vn equal limit as n tends plus infinity of 2 over 5 times minus half power n. 2 over 5 stay 2 over 5 because it's independent of n, but minus 1 over 2 power n as n tends plus infinity is 0 because minus half is between 0 and 1, so the answer is 0. We all know the definition, the property of the limit of a geometric sequence. If the r greater than 1, limit is plus infinity. If r between 0 and 1 or 0 or minus 1, the limit is 0, and if r less than minus 1, the limit does not exist. Part 4. Deduce that the sequence un is convergent and specify its limit. To find the limit of un, we have to find un in terms of n. We found Vn in terms of n. We found that Vn equal un minus 1 over un plus 1. If I can find un in terms of Vn, so I can find un in terms of n and calculate its limit. So I'm going to say Vn over 1 cross multiplication of Vn un plus 2 Vn equal un minus 1. So Vn un minus un equal minus 2 Vn minus 1. I can take now un as a common factor. بدل عنا Vn minus 1 equal minus 2 Vn minus 1. So I can say that Vn equal minus 2 Vn, I can say that Un equal minus 2 Vn minus 1 over Vn minus 1. I just found Un in terms of Vn. Why? Because now I can replace Vn by its value. It's minus 2 times Vn, 2 over 5 into minus half power n minus 1 over Vn, 2 over 5 into minus half power n minus 1. Now I found Un in terms of n, and I can calculate its limit. So we obtained that Un equal, I'm gonna expand minus 2 times 2 over 5 minus 4 over 5 into minus half power n minus 1 over 2 over 5 into minus half power n minus 1. This is Un in terms of n. To calculate its limit as n tends to plus infinity of Un, limit of minus half power n is 0, minus 1, and here limit of minus half power n is 0 times this number is 0, minus 1. Minus 1 over minus 1 is plus 1. Plus 1 is the same limit that we obtained when we used this equation. Who is it? Okay? And that's how we finish exercise number 33. A little bit complicated, يعني hard calculation, complicated calculation. Now we are going to solve another exercise. Exercise number 37. Okay. Consider the sequence Un defined by, I'm gonna write the given Un equal n plus 2 plus 2 ln n, n plus 2 ln n, n plus 2 of ln n, n belongs to n star. And we don't start with u0, we start with u1. We have another sequence Vn equal defined by Vn equal n squared over exponential of Un. Show that Vn is a geometric sequence. I'm gonna find Vn in terms of n, okay? Equal n squared exponential of Un, exponential of n plus 2 ln n, equal n squared exponential of a sum is the product of the exponentials, is exponential of n times exponential of 2 ln n, equal n squared over exponential of n. 2 ln n is the same as exponential of ln n square. يعني هيدي 2 فينا نطلعها لفوق مثل ما مذكرين. r ln a equal ln a power r. 2 ln n بتصير exponential of ln n square. Now equal n square over exponential of n times exponential of ln n square. Exponential with ln, they do cancel each other because they are inverse function. E مع ln بتروح مثل ما نحن متفقين. شو بضل معنا n square. We can simplify by n square and the answer is 1 over exponential of n. I found Vn in terms of n. Okay. Now I can show that Vn is a geometric sequence. I have Vn equal 1 over exponential of n. So Vn plus 1 equal 1 over exponential of n plus 1. I can calculate Vn plus 1 over Vn equal 1 over exponential of n plus 1 over 1 over exponential of n. I'm gonna make this product equal exponential of n over exponential of n plus 1. When we divide two powers with the same base, we subtract the exponent equal exponential of minus 1, which is 1 over a. The answer is a constant number, so Vn geometric sequence with common ratio r equal 1 over e, and first term v1. We can't say v0 because we have n belongs to n star. Vn v1 equal 1 over e power 1 is 1 over e also. Okay, v1 equal 1 over e صح. طيب. And determine its ratio and first term. Okay, very good. He didn't ask is geometric and convergent. How do we know that it's a convergent sequence? We can calculate its limit. Limit as n tends to plus infinity of Vn equal limit as n tends to plus infinity. We can write it in two ways. We can keep it in this way. We will obtain 1 over plus infinity is 0, or we can write it 1 over e power n. Since 1 over e is less than 1, so the answer is 0. This is part 1. Now part 2. Calculate the sum Sn equal V1 plus etc. till Vn. The formula is first term V1 times 1 minus r power number of terms here is n. From V1 till Vn we have n terms over 1 minus r. يعني equal 1 over e times 1 minus 1 over e power n over 1 minus 1 over e. Calculate limit of Sn. Limit as n tends plus infinity of Sn equal 1 over e is independent of n. 1 minus 1 over e, its limit is 0 because it's less than 1, over 1 minus 1 over e. And the answer is 1 over e minus 1 over e equal 1 over e minus 1. This is exercise number 37. Okay. بالحقيقة ما فيهم شيء، هن شوية calculation هيك معقدة لا أكتر لا. بضل عنا exercise واحد رح نعمله سوا، هو الدورة الوحيدة اللي إجي فيها sequence as a sequence. يعني بكل الدورات السيكونس اللي إجوا كانوا integral. أوكي، وكانوا part من درس الفانكشن. هذه الدورة الوحيدة اللي لقيتها فيها exercise sequence independent. ما بعرف إذا في من قبل، فتشت من 2004 وبالجاي. هيدي الدورة الوحيدة اللي فيها سؤال sequence independent من أي سؤال تاني. هي دورة 2015 العادية، يعني في أول first session، أول دورة. خلينا نحط لا مش انت. عملت له Ctrl C على هيدا هو. Exercise number 3 and session on the session of 2015, the first session. كان عنا exercise معنا sequence un defined by u1. Gonna write the given u1 equal 1 over 2 and un plus 1 equal n plus 1 over 2n un. Part 1a. Use the mathematical induction to prove that un is greater than 0 for n greater or equal to 1. Okay. Again, we have to show that the property that un is greater than 0 for n greater than 1 by induction. Again, for the first term, for n equal to 1, we have u1 equal half is greater than 0, so it's true. Assume that this property is true to the order n. It is true to the order n. And show that it's true to the order n plus 1. So the given, now that it's true to the order n, un is positive, and the required to prove it's true to the order n plus 1, so we have to show that un plus 1 is greater than 0. Proof. We have un plus 1 equal n plus 1 over 2n un. As you know, 2n is positive because n is greater than 1, and n plus 1 and n plus 1 is positive, and un is positive. So all the terms are positive, so un plus 1 is positive, and the property is true. This is part A. Part B. Prove that the sequence un is decreasing and deduce that un is convergent. To show that sequence is increasing or decreasing, it means to study its variation, we have to calculate un plus 1 or minus un. It's one of the methods, the other methods that we explained before. Un plus 1 is n plus 1 over 2n un minus un. We can take 2n as a common factor, يطلع معنا equal n plus 1 into. We can take un as a common factor, okay. N plus 1 over 2n minus 1. We can take 2n as a common denominator. يطلع معنا 2n n plus 1 minus 2n equal un into minus n plus 1 over 2n. As I know is that un is positive and 2n is positive, but I still have to know the sign of minus n plus 1. I can say that minus n plus 1 is negative, or I can prove it. You know that n vary from 1 till plus infinity in this exercise, and minus n plus 1 admits 1 as a root, opposite sign of a and same sign of a. After the root you do have the same sign of a. Since minus n plus 1 is less than 0 for n greater than 1, so un plus 1 minus un is negative, then un is decreasing. And deduce that un is convergent. Un is decreasing and bounded from below by 0. It's decreasing and bounded from below, then un is convergent. Okay. We finished part 1. I'm gonna solve part 2, so I'm gonna erase what I wrote here. Okay. همحيهم هلا. هخلي الجيفن هو اللي محينيه هون. مني أعرف إنه un هي positive. I need to know that un is positive. Part 2, we do have another sequence, auxiliary thing equal len of un over n. I'm gonna write it in the form len of un minus len n. Okay? To prove that the sequence Vn is a arithmetic sequence whose common difference d equal minus len 2. To show that Vn is an arithmetic sequence, I need to calculate Vn plus 1 minus Vn. But before doing that, I need to find Vn plus 1. Vn equal logarithm of un minus logarithm of Vn. So Vn plus 1 equal logarithm of un plus 1 minus logarithm of n plus 1. Equal logarithm of un plus 1 is logarithm of n plus 1 over 2n un minus logarithm of n plus 1. As you know, when logarithm of a times b equal logarithm of a plus logarithm of b, we still have minus logarithm of n plus 1. هامحي هون بس لحتى أكفي حال. Equal logarithm of a over b equal logarithm of a minus logarithm of b plus logarithm of un minus logarithm of n plus 1. plus logarithm of n plus 1 minus logarithm of n plus 1 vanishes, and the answer is logarithm of un minus logarithm of 2n. I can also write logarithm of 2n as logarithm of 2 plus logarithm of n. في minus outside بتصير minus logarithm of n. إذا كان بدكم كان فينا نعملها من هون. Logarithm of 2n can be written in the form logarithm of n plus logarithm of 2. Again, we did calculate Vn plus 1 and we found logarithm of un minus logarithm of n minus logarithm of 2. Vn plus 1 minus Vn equal logarithm of un minus logarithm of n minus logarithm of 2 minus Vn is logarithm of un minus logarithm of n equal logarithm of un minus logarithm of n minus logarithm of 2 minus logarithm of un plus logarithm of n. ln of un minus ln of un vanishes, minus ln of 2 plus ln of 2. The answer is minus ln of 2, so Vn geometric sequence with r equal, it's not a geometric, I am proving an arithmetic sequence. Vn is an arithmetic sequence with common difference d equal minus ln 2, and we need to find the first term. The sequence starts with v1, so this one starts with v1, and v1 equal logarithm of u1 minus ln of 1. And this relation, I just replace n by 1. The logarithm of u1 equal logarithm of half minus logarithm of 1 is 0, v1 equal minus logarithm of 2. As you know, ln of 1 over 2 equal ln 1 minus ln 2, and ln 1 is 0. Part B, express Vn in terms of n. You know the formula of an arithmetic sequence, Vn equal V1 plus n minus 1 d. So Vn equal V1 minus ln 2 plus n minus 1 times d is ln 2. So it's minus ln 2 plus n ln 2 minus ln 2. يعني minus 2 ln 2 plus n ln 2. يعني في n. If I did expand it هيطلع معي minus ln 2 plus n ln 2 sorry هون minus ln 2 t هو minus ln 2 هيطلع معي minus ln 2 minus n ln 2 plus ln 2 هكتبها minus ln 2 minus n ln 2 I'm expanding it plus ln 2 minus ln 2 plus ln 2 vanishes لكن Vn equal minus n ln 2. And this is part B. I still have verified that un equal n over 2n. محي هلا همحي هاي الميلة اوكي راح اعتبرهن انه un equal okay. We have Vn equal logarithm of un over n, again so ال Vn هي minus n ln 2 أو في يكتبها ln 2 power minus n equal logarithm of un over n using exponential function بشيل اللوغاريتم بيطلع معي un over n equal 2 power minus n 2 power minus n خليني بظبطها هاي الكتابة كلها لكن un over n equal 2 power minus n اللي هي 1 over 2 power n I'm gonna multiply by n here بيطلع معي إنه un equal n over 2 power n and I just found un in terms of n يعني ضربت هيدي ال n وين فوق فطلع مع الانسر اللي هو بده اياه اوكي طبعا هيدي إذا عملت لها ليميت راح يطلع معي انفينيتي على انفينيتي اي اف إذا طلب ليميت يعني هيدي هيك بتكون خلصت الحصة شكرا لكم على المتابعة أي حدا عنده استفسار يحكيني. يلا سلام.